So hello everyone, in the last session we are seeing about the circuit theory. So let us start with the discussion. So in the last session we have seen about the some basic concepts. Basically we have talked about the series parallel combination. So in this session we will first see about the series parallel combination, that how to solve a circuit by using series parallel concept, and then we will move to one more concept of solving the circuit, that is called as a KCL, by Kirchhoff's current rule. Okay, so let us start now. So the first thing we are going to talk about is the few example I have bring to you, and I have also solved this. Basically, if you see this circuit, just I want you to note down this circuit in your notebooks. So I hope you have done. So let us understand how to solve this by using series parallel. There is a one method, that is by using a what? By using which method? Simply you take a potential 0 at one point and then start writing the potential at every point and then solve it. But sometimes it is easier to apply the series parallel combination and solve the circuit in more quicker way as compared to other. That's why I am explaining you all the concepts, so that by seeing the circuit you can understand properly then which type of concept I have to apply to solve that circuit. Clear? So let us start. If you see this first example, my question is here, you have to find the current in this branch. So how to analyze the circuit? First you have to see that whether you are able to apply the series parallel combination, or first thing what we have learned, first thing, the potential zero concept. Take potential 0 at any point. Suppose if I take 0 at this point, okay, suppose this point is 0, this point is 20, but again there is a resistance in the path will come, so I cannot write the potential at other points. That will create a problem. So that is not a correct approach to solve this. So it is better, there is some other method is also there, but now it is better if you apply the series parallel combination. So let us see how to apply it. Basically what we can see from here, that if you properly see, the 4 and 2 are the series combination, correct? So just they add them, it will become 6. Now 6 and 3 are in parallel combination. So parallel of 6 and 3 is, we know when the two resistors are in parallel combination, then what is their equivalent? That is R1 into R2 upon R1 plus R2. So they will become 2 ohm. Now that 2 ohm will be series in 2 ohm, correct? So this will become 4 ohm. Now 4 ohm is a parallel with 4 ohm. So what is the net resistance? 2 ohm. So net resistance for this is 2 ohm. So what is the current you will get? 20 divided by 2, that is a 10 ampere current is leaving from this battery. Now this 10 ampere current has to divide and go to this path, and one path is this path, correct? If you see, what is the R equivalent for this path is 4 ohm. What is the R equivalent for this path is 4 ohm. So if two resistance, they having a same, if the two resistance are same, and if you are and they are connected in parallel, and you are talking about the current division, then obviously the current will divide equally. If you apply the what is the rule to do the division, current division? I1 is to I2, that is what, 1 upon R1 is to 1 upon R2. So this R1 R2 will cancel out because they are equal, so 1 is to 1 ratio, that means equal division. So that's what I am also saying. So that means the current will divide equally. So here 5 ampere will go and here 5 ampere will go. So what is the current in this branch? 5 ampere. Clear? Now similarly come to this question. If you see this question we have seen earlier also during the example. What simply you have to do here, it is better to apply what? Here it is better to apply the potential zero concept. If you apply the potential zero here, you can directly write the potential 10 volt here, correct? And this will be also 10 volt, this will be 0. So obviously you can know that, you can directly know the voltage across this resistance 2 ohm, because we want to calculate the current in this. So 10 divided by 2, that will be 5 ampere current in this branch. I hope it is clear now. Clear? Okay. I hope no doubt is there. So let us move to this point. If you see this point properly, there is a 20 volt battery is there. This is the same circuit. 20 volt battery is there. What basically question is that current in this branch? Again same thing. These two are in parallel, so 2 ohm. 2 ohm and 4 are 6 ohm. 6 ohm parallel with 12 ohm. That is how much? 4 ohm. 4 ohm plus 1, that is 5 ohm. So what is the current will flow? That is 4 ampere. Now 4 ampere has to divide here. In this branch, what is the net resistance? That is, if you will see, what is the net resistance? 6 ohm. So that is what, and this whole resistance is how much? 12 ohm. So I have divided into 1 by R, like R2 is to R1 ratio. So that is a current in this branch, and this current has to go into this branch, and this again there is a current division rule we will apply, and we will get the current as 8 by 9 ampere. I hope it is clear now. Let's come to this question. Again the same question, same type of concept. These two are in series, that is 4 plus 8, that is 12 ohm. 12 ohm parallel with 6 ohm, again it is 4 ohm. 4 ohm plus 2, that is 6 ohm. 6 ohm is parallel with 6 ohm, that is 3 ohm. 3 ohm plus 2 ohm, that is 5 ohm. So what is the current will flow? 2 ampere. Now if you will see, the whole resistance of this path is how much? That is 6 ohm, and the whole resistance of this path is also 6 ohm. So current will equally divide. So what is the current in this path? That will be 1 ampere, and what is the current in this path will be 1 ampere. So that's why the current is 1 ampere directly. Okay, no need to even do the calculation in this question. Now I want you, basically I have given the answer for this. Now I want you to do this as a homework, and for this also try to do this as a homework. Okay, clear? Try to this and this both as your homework. Clear? Now let us talk about a circuit by using KCL. Okay, so basically when it's come to solve the circuit by using KCL, what is the concept here? See, whatever the type of circuit we have seen till now, if we try to understand whatever the example I have taken, that whole example is either we are able to write the potential in that circuit, as you can see in these examples. It is easy for you to write the potential of across any resistance. You can easily find the potential across any resistance, but it is not always true. It is not always true we can find the potential across any resistance. Okay, it is not always the case. Like here, if you can see, here we are able to apply the series parallel combination, but it is not always true. There may be some type of circuits will come into the picture where you can't even apply the series parallel, or where you can't even apply the this zero potential concept which I had started or told you in the starting of the sessions. So here the approach comes is the KCL. No one have, I don't know whether you have solved the question by using the KCL or not. So let us understand what is KCL basically. See, approach is same. First step is what? You take zero potential at any one point. Any one point. It is your desire. But I told you it is 85%. It is obvious that if you take the potential zero below the ground, below point, then it is very much beneficial. Then what you have to simply do? You have to take the zero potential at this point and start writing the potential at other points. Like if this is 0, this will be 10. Now this you can't write some value. Why? Because there is a resistance in this path. So you let us assume it as x. If this is x, this will be also x. But again here I cannot write. So let us take y. If this is y, this will be also y. Correct? Till here, anyone have a doubt in writing the potential? Please tell me, or please understand what I have told you. Just you have to write the potential. Okay? Just write the potential. If you are not able to write the potential of any point you don't know, just take it as a variable. We will find that value of that variable. Simple. Just take it as a variable. Don't note the solution, just note down the potential, like how we write the potential. Completed? Okay, note it down. Okay. So have you written the potential? Now, what you have to do, basically we have a two unknowns. So we have to apply the KCL 2 times. If there are 3 unknowns, we have to apply the KCL 3 times. Listen each and every step very properly. So 2 KCL we have to apply. First you have to apply the KCL at this point. What does KCL say? The outgoing current is equal to incoming current. And assume the outgoing currents are I1, I2, I3. You don't know. It can be opposite also. It will come into the, while solving it will be answer, you will get the answer like that. But for now, just as assume that I1, I2, I3 is going like this. And just write the KVL equation and then write the I1 value, I2 value, I3 value. Now how to write I1? See here. I1 is a current in this branch, and that is a current across this resistance. This potential is 10, this potential you don't know, it is x. So x minus 10 divided by 2 is what? That is I1 here. Similarly, what is I2? That is x minus 0 divided by 3 is I2. What is I3? X minus y by 2, that is I3. Similarly, and then solve this equation. Similarly, for point 2, you apply and make an equation and solve these two equations, equation number 1 and equation number 2, and you will get the value of x and y. Please note it down, and anyone have a doubt till here, please let me tell me. Otherwise, if you have a doubt, please tell me. I hope you are getting my point, what I am trying to say. Okay, just what you have to do in any type of circuit, first start write a potential 0 at one point, and then start writing the potential of other point. If you are not able to write, take it as some variable x or y and then apply the KCL at that point or that node. It is basically a node because we have more than 2 junctions are there. That is a node. And after, if you write the KCL, then try to solve that equation and you will get the value of sorry. Okay, so you will get the values. Clear? Any doubt here? Note it down. Sorry. Completed? Okay. So let us take a one example. Sorry. Try to solve this example. Okay, I want you to calculate the current across this. Okay, you have to simply apply the KCL. Okay, and try to solve this. Calculate the current. Then after that, we have to, after learning this concept, you can solve any circuit, it does, like I told you, I had told you in the starting of this current and electricity only, by KCL and KVL you can solve any circuit, and that is a magic. You can solve any circuit. Okay, so what we will do, we know only one method. Take 0 at some point. This will be 0, this will be also 0, this will be also 0, and obviously this will be 3 volt. Correct? Any doubt till here? Okay, now here potential I don't know. Correct? So let us take it as x. Okay, here also I don't know. Let us take it as y. So this will be also y. Okay, if this is y, then this will be how much? Y minus 2. Correct? Now we have to apply what? We have to apply what? We have to apply KCL. Now my question is that whether you have to apply KCL at 1 point or 2 point. How many point? Only 1 point, because this is the node. This is not a node. This is not a node. Okay, see here, this is a node, this is a node. Okay, why you will apply KCL here? If you want, you can write it like this also, na? If you can remove this 5 ohm, simply what you can do, you can directly write it this as a 8 ohm. That is in series combination only. This type of things the examiner may do. Okay, they will break this without any reason. So don't stress. Just combine them. It is a 8 ohm. Now there is no need to, like, you can. So again, this will be y only, na? That's what. So that is not a big issue. You can do like this. So that's what I'm saying. If it is written, just leave it. No issue. Okay. Then start applying the KVL across this. KCL at this point at y. So if you apply a KCL at y, what is the approach? I1, I2, I3. So what is a KCL says? I1 plus I2 plus I3 should be equal to 0. What is I1? I1 is simply, if you write y minus 2 by, how much is this resistance? Suppose take it as 2 ohm. Okay, by 2 ohm plus, what is the I2? I2 value is simply y minus 0 by 8. Correct? And what is I3? Y3 is, if you will write y minus 3 by 6, that is equal to 0. Then solve this. What is the value you will get? Y by 2 minus 1, y by 8, y by 6 minus 1 by 2 is equal to 0. Y, that is 5y by 8, y by 6 is equal to 3 by 2. Correct? Any doubt till here? Okay, so you will get 5y by 4, y by 3. Okay, then you will get 15 plus 4, that is, okay, 15 plus 4 is how much? Is 19, y by 12 is equal to 3. So what is y? Get 36 by 19 volt. 36 by 19 volt. So you know this potential now. So can you find the current in this branch? What is the current? That current is nothing but it is minus times of I2, because they both are in opposite direction. I want this I. So I2 is just opposite of I. You just calculate I2. What is I2? I2 you know that is y by 8. I2 is y by 8. So just put this value here. 36 by 8 into 19. That is how much you will get? How much you will get? 9 by 38 ampere. Simple. Are you getting my point? So this is how you can solve any circuit. Now you can solve any circuit which can be asked in any competitive exam regarding circuit theory. This is circuit theory. I hope it is clear till at this point. Now I can give any circuit and ask you current in any branch, potential at any point, anything I can ask you. Okay, just you have the very important tool, that is, and if you go for hires, you will learn this rule as a name of nodal analysis. They will tell you these steps you have to follow. Basically it is a nodal analysis only, but it is basically an application of KCL. Okay. Just note down this. I hope it is clear. Any doubt? Okay, so in this session we are covering this much. In the next session we are going to start the separate. Basically I want to make this as another session. So we will start the calculation of equivalent resistance, because that is a very important part, and that is a lot of times lot of questions has been arises, and we will see what is mirror symmetry, what is horizontal symmetry, what is perpendicular, lot of things we will see, vertical mirror symmetry, horizontal mirror symmetry, and we will understand everything. So I am making this as a next session. So in this session that much is here. In the next session we will do the calculation for the equivalent resistors. Till then, take care, goodbye, and if you like this session, please like it, share it and subscribe it, and have a nice day. Thank you.